If you have any questions for Politics and Science, you can direct them by email to politicsandscience@madriver.com. That's politics, A-N-D, science, @madriver.com. Politics and Science can be heard weekly on WMRW LP Warren 95.1 FM, airing on Mondays at 5 p.m. and Sundays at noon. And in the Bellows Falls area can be heard on Wool LP Bellows Falls at 101.1 FM, airing from 3 to 4 p.m. on Sundays and from 9 to 10 a.m. on Mondays. Politics and Science presents the viewpoints of its participants and does not necessarily reflect the viewpoints of any other person or organization. And we should be talking to Ray Peat. Ray, can you hear me?
Yes, I'm here.
Very good. Welcome again to Politics and Science. And last week we were talking about metabolism, oxidative metabolism, and what's the other? Glycolysis, I guess, which is...
Yeah, glycolysis forms lactic acid from glucose.
And we were doing that in the context of what it is to be a healthy person. And having, Ray said, not only enough energy to get your tasks done, but also enough to regenerate the damage that inevitably happens to everybody as they go through daily life. And I thought you said something last week which I thought was interesting, which was that we regenerate 25 to 30% of the fats in our brains every night, I think you said.
Yeah, there are different ways to look at it. It might even be more than that if you think about taking a phospholipid apart into its components and then rebuilding more phospholipids so that a chain will exist as a unit but be rebuilt into a bigger structure. That kind of turnover probably is more than 20 or 30% during the night. You can see 25% of that kind of turnover in, I think it was less than an hour in some animal studies, but if you look at the actual oxidation and renewal of particular fats, so that a fat is broken down into carbon dioxide, for example, and then new fats come in from the bloodstream, that's more like 5% per day. If you look at just arachidonic acid, for example, which makes up a considerable amount of the fat in the brain, that changes and is renewed by the bloodstream about 5% per day.
Can I ask a dumb question? Why are we regenerating fats?
The brain is metabolically very active, and when you stress a rat, the turnover in the brain is even faster than at rest. But the brain is adapting for the whole organism and thinking up new ways to handle the environment. And whether you put a rat in a tumbling drum to stress it or just have to go through the 8 or 10 hours of darkness during the night, they're both stressful, and the brain is trying to deal with the stress and make innovations or adjustments that help the body to cope with the next day's tasks.
So the original fats are being burned, or are they just getting oxidated? And
a small amount, like 5% or so, maybe more, are actually being oxidized, and a larger amount, maybe 30 or 60%, something like that, is being reshuffled from one molecule to another, so that there are many types of phospholipids and other fats in the brain, and the subunits can change around so that the functions of the nerve cells are adjusted as the type of phospholipid changes.
I see. So, and when we're regenerating things like that, obviously you need enough energy to be doing that at night. And but if you don't have the energy to reproduce parts of yourself that are getting worn out or need to be adapted, what happens?
Well, the brain synthesizes and stores glycogen similar to muscles and liver, and with aging or stress, the glycogen is depleted, and it takes deep sleep to regenerate the glycogen. And the glycogen seems to be essential, even if you have circulating glucose. The glycogen is used for those stress adaptive processes. Having all of your biochemical machinery available, thyroid and the vitamins and minerals and so on, is necessary, but then the deep sleep is needed to restore the glycogen so that you can meet the next stresses.
I see. So when you're trying to regenerate and trying to get enough of the foods that you need to provide that energy, you've mentioned before that some foods are particularly unhealthy to your thyroid, which sounds like probably the key mechanism for keeping your metabolism up so that you have the energy available to use.
You want to avoid the specific anti-thyroid compounds, the goitrogens, that you find in a lot of vegetables, grains, and nuts.
Mm-hmm.
And the polyunsaturated fats are anti-thyroid, and tryptophan and cysteine that you find in muscle meats at a very high concentration are anti-thyroid.
So, and a lot of people, I think, I don't know if we've really talked in any detail about your theories about thyroid. I didn't properly introduce you. Ray Peat, we're talking to today, is an endocrinologist and a physiologist and a science historian. And as an endocrinologist, you have extensive knowledge about hormones, and the function of the thyroid gland is a key part of that, our physiological system, our endocrine system, I guess you'd say. And I was wondering, Ray, if you'd maybe explain the function of the thyroid a little bit, and then we could talk about how the thyroid is measured, thyroid function is measured in this day and age, and how that's changed over the years.
People think of the thyroid as being regulated by the pituitary hormone, TSH, which it's a major activator, but it's responsive to practically everything in the internal environment. If your estrogen is high, the enzymes in the gland become less responsive, and the gland accumulates rather than secreting hormone, and progesterone facilitates the enzymes that are needed to secrete the hormone. Polyunsaturated fats inhibit those same enzymes, and so if your body is experiencing a deficiency, your pituitary will increase the TSH, thyroid stimulating hormone, to try to get the gland to compensate. And if you have a lot of estrogen and polyunsaturated fats circulating, the gland will enlarge under the stimulation of the pituitary, but without secreting very efficiently. And during puberty and pregnancy, it's very common for women to have an enlarged thyroid because of the estrogen inhibiting the release of the hormone. And then with a change of circumstances or diet or having the baby when the estrogen goes down, sometimes there will be an episode of hyperthyroid function as that stored hormone can be released, and that will often scare the patient's doctor if they see their pulse running at 125 beats per minute at rest and their hands being pink and warm and sweaty. That's classical hyperthyroidism, but a lot of doctors will kill your thyroid with radioactive iodine or cut it out when they see symptoms like that, but it's really usually just a natural adaptive process in which the enlarged gland is returning to normal size, and it takes a few weeks usually to safely unload that amount of stored colloid or thyroglobulin. Some people have told me that they never felt better in their lives than when they were in their month or two of hyperthyroidism. But unfortunately, that's the opportunity for surgeons and radiologists to destroy the thyroid.
And go ahead, sorry.
In the 1950s, it was discovered that one molecule called T3 triiodothyronine is the active promoter of respiration, but it took decades for that information to circulate through the American medical community. The Japanese, Israelis, and Russians were the first ones to really assimilate that information. Since estrogen inhibits the activity of the thyroid, women are about 5 or 10 times as likely to have thyroid problems as men. But when one form of synthetic thyroid, T4, which isn't the active respiration promoter, when that was created chemically and became a product, it was tested on 25-year-old male medical students, good health, young males, and it was found to act just like the desiccated thyroid gland that had been used at that time for 50 years as a medical supplement. And so the marketers began selling it to females without really testing it on females because it worked on young men. But in fact, it very often interferes because the pituitary and brain will respond to it and shut off the thyroid stimulating hormone. And so it's good at turning off a woman's thyroid gland without necessarily being converted in the liver into the active form. An experimenter in the 1960s who hadn't assimilated the knowledge of the two hormones normally existing in a ratio of 3 or 4 to 1, this experimenter sliced up pieces of muscle, kidney, liver, heart, brain, and so on, and then added what he called the thyroid hormone, thyroxine, or T4, to the solution. And he found that it suppressed oxidative metabolism in the heart and muscle and brain. And the liver was the only gland that was strongly responsive to increasing its respiration rate in proportion to the amount of added thyroxine. And so he said he had demonstrated that respiration isn't the important thing done by the thyroid hormone, because how could it be important if the thyroid hormone suppresses the metabolism of the brain and the heart. But in fact, the liver is the source of about 70% of the active thyroid hormone that circulates in the bloodstream. The thyroid gland secretes a little bit, 25 or 30% of the active hormone, but the liver, as it senses the need for energy in the body, converts T4 to T3, and the brain doesn't have much of that capacity for activating the hormone, and so when the T4 increases beyond a certain small amount, it displaces the active hormone and suppresses brain metabolism. And I've seen that happen in numerous women. First time I heard about it was at the University of Oregon Medical School Hospital in Portland. A woman who had been on 1 grain of thyroxine for some time was getting worse, so they raised her dose to 2 grains, and every 6 months or so she would be worse, and so they would increase it. They finally reached the level of the equivalent of 5 grains, which was 500 micrograms of, I think it was Thyroid. And at that point she went into a coma called a myxedema coma, in which the skin and other tissues puff up with a gelatinous edema material, and she was deeply comatose. And luckily some doctor knew about T3 being the active hormone and gave her intravenous T3, and immediately she came out of the coma and was okay. But I've seen that happen to lower degrees in women who would lose their memory or concentration or get strange sensations, neurological symptoms when they were taking pure T4. But if they would take a balanced product like natural desiccated thyroid, their symptoms would disappear.
And how does estrogen become a problem in pregnancy? Because I thought that's when progesterone was high in the cycle.
Yeah, if a person is low in thyroid going into the pregnancy, or if they don't eat enough protein and certain vitamins so that the liver can function, the liver, in experiments, if you put a source of estrogen where it goes directly to the liver and measure the amount coming out of the liver, in a healthy person it's 100% going in and 0% coming out, meaning that the liver totally inactivated the estrogen. But if it doesn't have enough protein or certain vitamins, the liver can't inactivate estrogen, and so 100% goes in and maybe 99% of it still comes out. And so the estrogen is allowed to reach very high levels, and the thyroid would activate the liver metabolism and restore its ability to destroy estrogen. But it becomes a vicious cycle in which if your thyroid's a little low, the liver lets estrogen accumulate to a very high level, and that makes your thyroid go lower by blocking the gland itself. And so it's a vicious circle. And since thyroid is needed to synthesize progesterone, converting cholesterol into progesterone, what happens in that situation is that your cholesterol rises and your progesterone becomes very low.
I see. And that brings us to another common issue, which is many people have high cholesterol, and maybe you could I don't know, maybe you don't need to elaborate because you just said it, but...
Yeah, in 1936, papers were published showing that if you measure the cholesterol at the time a person's thyroid gland is removed surgically, there is a steady, sharp increase over the next few weeks in the blood cholesterol. And then when you put them on a thyroid supplement, the cholesterol returns to normal. And if you are charting the metabolic rate, the oxygen consumption of the whole organism, it's a mirror image of the cholesterol. The metabolic rate and oxygen consumption fall as the cholesterol rises under the hypothyroid circumstance. And if you supplement thyroid, just as the metabolic rate increases, the cholesterol decreases. And I've seen a couple people who were in a hurry to get their cholesterol down hundreds of points. One had 400 milligrams percent, the other one 500 and something. And they wanted to have a good physical exam, and they took the active T3 hormone in physiological amounts, roughly 5 micrograms per hour, and in a week they had restored their cholesterol to the normal range of around 200 milligrams percent.
That's remarkable. So is it just that a lower metabolism, you are not converting the cholesterol into the other steroids?
Yeah, some cholesterol is converted to form bile acids, steroids that help to emulsify fats in the intestine. But the formation of DHEA, pregnenolone, and progesterone uses a massive amount of the circulating cholesterol. For example, an experimenter put the bloodstream into an isolated ovary and then measured the hormones or substances in the blood coming out of the ovary. And the amount of progesterone coming out the other side of the ovary corresponded directly to the amount of cholesterol going into the ovary. And so if your cholesterol level was lowered, the progesterone produced by the ovary was lowered. And that experiment didn't adjust the other components such as thyroid and vitamin A that are involved, but those were kept at a functional level so that progesterone varied directly with cholesterol.
So when they're worried about the cholesterol, it sounds like really the cholesterol is just a sign that your metabolism isn't functioning well. And
yeah, and if you artificially lower the cholesterol, you tend to lower the adaptive hormones, especially progesterone. And the early studies, I think the first big one was done in Hungary. They saw that lowering cholesterol tremendously increased cancer mortality and total mortality, and increased death rate from accidents and homicide, and even heart disease and strokes.
So let me just interrupt. So to clarify that, you're talking about lowering cholesterol artificially through statins and stuff like that.
Yeah. Well, they were, I forget which chemicals they were using at that time.
What sounds like, I think you've said this before, the cholesterol, even if you're not turning it into steroids, the cholesterol itself is protective.
Yeah, since about 1920, they showed that just injecting pure cholesterol is protective against all the types of toxin that they tested, bacterial toxins, mercury, plant toxins, and so on. And it protects red blood cells from from being broken down by mercury and enzymic toxins, spider and snake poisons, and so on.
And yet there is evidence that a high cholesterol rate, when you get into the, I don't know.
Well, that's really just because you don't get a high excess cholesterol in the blood without being hypothyroid.
I see.
And you can correlate high cholesterol with lots of things, such as poor learning ability and so on. But in experiments, if you inject cholesterol right into the brain, it improves learning ability and nerve function.
I think I'll pass on that experiment.
It's the low cholesterol, the low thyroid, which is responsible for the high cholesterol, that accounts for the disease that they associate with the high cholesterol.
So when they say strokes are caused by high cholesterol, it's actually that you're just hypothyroid and your metabolism isn't functioning.
And when you can't make the protective adaptive steroids such as progesterone and DHEA out of the cholesterol, your body does its next best adaptive procedure, which is to increase the cortisol or cortisone, and the chronic elevation of cortisol, which is associated with high cholesterol and low thyroid. That's one of the toxic effects that you see in people with high cholesterol. The chronic exposure to excess cortisol weakens blood vessels, for example, and promotes bleeding, but it also can promote clotting and osteoporosis and various tissue degenerative processes.
But cortisol also has a positive purpose, doesn't it?
Oh, it protects you. If you don't have enough pregnenolone, DHEA, and progesterone, you need cortisol to handle stress. But the way it handles stress is to depress inflammation, but it does it at the expense of tissues such as your thymus gland, muscle, skin, and liver, converting protein to fuel to use for energy to combat the stress. So it's spending your organism rapidly to get you through a crisis situation.
I see. So it's an emergency adaptation.
Mm-hmm.
And then that sounds like it makes you even more hypothyroid, because you've explained before that when you start digesting your own muscle, that produces more antithyroid chemicals.
Yeah, it probably the cortisol directly signals the liver. They've done in vitro experiments that indicate that the cortisol is blocking the enzymes that convert thyroxine into the active T3 hormone. So it's doing many related things, increasing the circulating cysteine and tryptophan to suppress the gland itself, and changing several levels of physiology.
So that sounds like a difficult situation to get out of once you slip into that unhealthy state. Raymond, let me just interrupt for a minute. We're listening to Dr. Raymond Peat. We're halfway through the show, and Dr. Peat is an endocrinologist and physiologist and science historian out in Eugene. And we have a pretty weak signal again today, Raymond. It seems like that new phone is not working very well. I don't know. Is it turned up all the way?
Yeah.
Yeah, it didn't seem to improve. It could be our connection, possibly, that's messing us.
I hear some fuzzy static in the background.
Do you? Yeah, I hear it here too. I'm not sure if perhaps... I think it's all right if you talk straight into the phone, or do you want to try the other receiver? Is that handy?
No, I'll just talk closer to it.
Okay, that does sound better. So, well, it sounds like quite a downward spiral if you get into that low hypothyroid situation. And I thought, I hate to dwell on negatives, but I thought, now you've said before that you think they've changed the way they judge people's thyroid functions, such that in the 30s or so that they thought what percentage of people did they think were somewhat hypothyroid?
About 40%, I think, by the end of the 30s.
And that's a pretty huge number. I'm surprised they came up with that. And how did they decide what's normal and what isn't?
They were measuring the ability to extract oxygen and burn calories, and they saw that the lower a person's oxidative metabolism was, the more symptoms they had. And they found that giving desiccated thyroid to increase their oxygen consumption, the symptoms would be alleviated. And so they had a large list of diagnostic symptoms, everything from having yellow palms of the hands, soles of the feet from accumulated keratin, infertility, which they found was associated very often with red spots in the ovaries. The corpus luteum it means the yellow body, but in hypothyroid people it was found to be a red body because it contained so much keratin. And the keratin was blocking the conversion of cholesterol to progesterone because vitamin A is needed, and low thyroid people accumulate the keratin because they aren't using the vitamin A fast enough, and then they can't convert cholesterol to progesterone and become infertile. Same process happens in the adrenals and the testicles and in the brain. Any place that vitamin A is used to, vitamin A is needed to antagonize estrogen in probably all cells, including the skin. And keratin accumulates and interferes with the use of vitamin A, and so you could just look at a person's palms and very often diagnose hypothyroidism. But falling hair, thinning skin or thickening skin, either one, depending on their cortisone response, sweating excessively or not at all, and if a person had been chronically hypothyroid, their growth was usually either deficient or excessive. Very often people who hadn't reached an average height were found to grow to a normal height when they took thyroid, and the people with an excess of growth hormone were found to lower their symptoms of acromegaly if they took a thyroid supplement.
So how does they probably, well, maybe they try to explain it. How would they explain that we went from 40% of the population was hypothyroid to now? What do they consider the level to be now? It's much lower, isn't it?
Well, when they did that experiment on medical students and showed that the synthetic hormone supposedly worked just like the real stuff, that went with an advertising campaign. When I was in junior high and high school, all the fat kids were reciting what they had heard from their doctor, that they were just gluttonous and lazy and didn't have a hormone problem. Because a blood test was circulated at that same time that measured protein-bound iodine, and that test showed that 95% of the population were normal. Only 5% had a low protein-bound iodine content. And so even though at least 40% of the people would have benefited according to the pre-war diagnostic methods, if they got anything, it was likely to be the inactive thyroxine rather than the real active hormone, and that contributed to the belief that since people didn't benefit, that confirmed the idea that 95% of the people at least were not hypothyroid. But about 20 years later, the protein-bound iodine test was found to have essentially nothing to do with thyroid function. And what it had accomplished, though, was to teach doctors that whole picture of things, that only 5% at most would need a thyroid supplement, and when they got it, it probably wouldn't help very much because it was likely to be the inactive thyroxine. And so over the years, new blood tests came out that actually measured the various thyroid substances in the blood, but they kept the doctrine that 95% of the people were not hypothyroid. And so their normal definition made the new tests irrelevant.
I see. So they adopted that foregone conclusion that a certain percentage were normal and based everything on that. Huh. So that's a little bizarre that they would fall for that, but I guess they're often confused by they adopt markers as indicating a condition. Is that right? They adopt sort of these medical blood test markers, and then
and one of the problems with the work up to the 1930s with thyroid was that everything from cancer and heart disease to dry skin and falling hair were known to be caused by hypothyroidism, and that sort of ruined the medical business if you could cure everything practically with a thyroid supplement. And so they said the belief in a panacea is irrational, and we have to be scientific, and each disease is a separate thing that we have to study and treat with a specific remedy.
I see.
I just happened to run across an article about published by a big medical publishing company. I think it was Lippincott, and the subtitle was something about panacea for the next millennium, estrogen receptor modifiers. So if the industry supports a panacea, you can talk about it, but the fact that thyroid supplements had functioned as the equivalent of a panacea was used as propaganda against it, that it was irrational quacks who wanted to cure everything with one pill.
Right. So it didn't fit into reductionist thinking, I guess, where you have all those specialties. So continuing on, talking about thyroid as a common problem and something that affects all of us in our health. So if your thyroid isn't functioning, it sounds like we were talking about cell regeneration in the beginning, and it sounds like it's a key part of providing the energy for you to regenerate. And what happens to your cells when you don't have the energy to regenerate? Do you?
The cell will start the process. When a cell is injured, that accelerates renewal and healing. And one of the signals for starting accelerated renewal and healing is the fact that the damaged cell doesn't respire properly and doesn't use its thyroid environment to good effect. And so it shifts over to the injury metabolism of glycolysis, producing lactic acid. And lactic acid stimulates the growth and invasion of blood vessels and the acceleration of cell division and secretion of connective tissue collagen. And so injury damages the thyroid-governed metabolism and starts up the process of accelerated renewal of the tissue. But if you don't have the proper thyroid available when the tissue has recovered, the tissue might still stay in that stress or injury adapted condition and go on producing lactic acid and stimulating cell multiplication, collagen secretion, and all of the wound adaptive processes, increased formation of blood vessels, and clotting very often is accelerated. So if the whole body doesn't have enough thyroid and other supportive hormones, the injury can develop into a tumor. But normally, if your thyroid is functioning properly, instead of having those locally accelerated regenerative processes every place there's an injury or stress, the whole body is normally slowly and at different rates according to the local needs. The whole body is renewing itself in a process of tissue streaming or organ streaming, in thinking of the cells as like a fountain of cells coming out of one part of the organ or tissue and growing and functioning and then disappearing in another part of the tissue. In the cornea of the eye, for example, they've applied a dye and found that the cells literally stream over a period of days from the edge of the cornea up onto the cornea, constant movement of cell renewal creeping over the surface of the cornea. And in the liver and adrenal glands, skin, and the intestine, people have demonstrated this constant renewal, streaming or flowing of new cells into the tissue and the disappearance of old cells. Blood supply is an example of that. New cells are born, live for about 3 months, and then disappear, and the material is recycled. Every tissue is undergoing that kind of a renewal from stem cells. But that, for various reasons, even though the research was done, Alexis Carroll, for example, at Rockefeller Institute in the early years of the century, and then Polizhayev, a Russian researcher in the 40s and 50s, demonstrated regeneration and renewal even in the brain. And Polizhayev was regenerating whole dog muscles in the 1940s, but that violated one of the main medical biological doctrines of the establishment was creating a particular business model of medicine and biology that took over very completely in the late 1940s, and the idea of organ regeneration as a normal biological process was just stamped out very thoroughly, so that people thought of aging as a simple natural process in which each cell had its finite lifespan, and when that was used up, the organism would die. And you can see it in still many doctors believe in the ovary having a certain number of eggs when the woman is born, and menopause occurs because they have depleted their lifetime supply of eggs. The same thing applied to the lifetime supply of brain cells or heart cells or whatever. The idea was that they had a finite lifespan, but in fact, for 100 years, the evidence has been showing otherwise, but it just wasn't admitted into mainline science and medicine.
And it sounds like it was there before the 40s, and it basically got stamped out?
Yeah, it was developing nicely up through the 30s. The idea of a developmental field it was taken from embryology and was being applied to cancer physiology, even though the first person to theorize about cancer having a field was, I think, in 1830, but it had developed a good scientific context by 1930 and was being integrated with embryology. The aging process was being seen as nothing but an extension of embryological development, and that was seen in terms of wholes or fields rather than each cell being an individual running on a clock, sort of do you know Leibniz and his monad theory, in which there's no interaction between the monads? Every individual cell or person has its internal model of the universe running like a clock, and it doesn't matter where it is, it'll do the same thing. That really was the model that took over medicine after the Second World War. And I've talked to many doctors who said maternal nutrition during pregnancy doesn't matter because even if the mother is almost starving to death, it isn't going to hurt the baby's development. It's really the Leibniz monad doctrine that nothing interacts.
I see. It's more of the reductionist thinking that everything is a separate, independent piece.
Yeah, reductionism to the point of psychosis.
I'd say that's true. So when you're talking about regeneration, you mentioned Hayflick last week as being one of the person who did the experiment that ended up convincing most of science that you can't regenerate, only a certain limited...
Yeah, the fact that he worked at a very influential laboratory that sold biological material, cell cultures and such, and rats to laboratories all over the country, that helped to give him a reputation. People just assumed that an idiot wouldn't be working for a big company like that.
I see.
But I don't know whether, I suspect, in one of my newsletters I give reasons for suspecting that he wasn't as stupid as he seems. For 30 years I thought he was just a very remarkably stupid person, but then I saw he had financial motives that might save his mental reputation.
Not his moral reputation, but his mental one. Boy, yeah, and it makes me wonder, where the peer review process was when he came up with those results, because that's what.
It's pretty much where it always has been. Like I've been following the estrogen receptor doctrine for many years, and the promoter of that came up with his idea. He was working in chemical warfare, and he even titled one of his articles "From Chemical Warfare to Breast Cancer Treatment." And in making that transition, he created the idea of the estrogen receptor as what makes estrogen effective in the organism. But the biologists had been demonstrating how estrogen is metabolized and how the metabolism of estrogen is integrated into cell physiology in meaningful ways that relate to oxidation and reduction. And it was a little complicated, but very well founded in all of the known information about enzymes and metabolism. But this Elwood Jensen got, because of his military connection, he got funding and support from the Atomic Energy Commission. It was extremely expensive to create a molecule with radioactive isotopes labeling it, but the Atomic Energy Commission provided the stuff, and no one else had the funding or the government permission and support to do similar experiments. But on the basis of his experiment, he claimed that estrogen is not oxidized in the tissue, doesn't participate in enzymic oxidation and reduction. He said it only acts through this protein, which he called the estrogen receptor. And that, because of the prestige of his funding and his government support, and is using a fancy technical experimental procedure that no one else could get, he shaped the whole biological culture. And these enzymologists that he said were just ignorant, incompetent, old-fashioned fools, they kept on working, and now everyone knows that they were right, that estrogen is reduced and oxidized. Estrone turns into estradiol and back and forth, and the reduction is what makes it toxic as an estrogen. But the culture served its purpose and created the whole industry of estrogen receptor selective modifiers, the panacea of the next millennium.
And all those the receptor idea is do you think there's such a thing as a receptor, as a place where things plug in?
Yeah, the whole cell is a receptor.
Okay.
It's like a perceptual process, because the state of the cell governs what the receptor is going to do. The cell is in charge. The receptor can do one thing or another depending on what the cell needs and how the cell is using its perceptive capacity.
It just seemed the receptor idea was such a good marketing ploy, because it fits our need to have one thing do one other thing.
Yeah, it's a perfect model of reductionist biology that really has no sound scientific basis.
I just got a book out of the library called The Secret History of the War on Cancer, which I haven't had much of a chance to read, but just I was kind of amazed. Glancing through it, I read the preface, and she had some amazing quotes. It's written by Devra, D-E-V-R-A, Davis, and I think it's a fairly recent publication. But she talks about working at the NSA and how she had a theory that a lot of cancer was caused by environmental things, and she was going to write a book about it. And her boss, Frank Press, said that, let's see if I can find the quote. He nodded as I told him of my plans. He said gravely, "It had better be a good book." I replied, "Well, I guess they think it will be. They're offering more than half my annual salary. That's quite a lot for a first-time author." "It had better be a really, really good book," he said. I didn't understand. "Of course they expect it to be good," I said. "So do I." "Well," he said, "it had better be, because you won't be able to work here after you write it." And I guess she added that he was a very consummate diplomat, and he knew how things worked there. So that's the NSA, which is the National Academy of Sciences. Is that a government? That's a government.
NAS or NSA?
NAS, excuse me.
Oh yeah. Well, I wouldn't be surprised if the NSA was involved too, because following up Elwood Jensen's Atomic Energy Commission connections and germ warfare, I found that the estrogen receptor gene people have been involved in military-financed sterilization and cancer studies, continuing through the University of Chicago, and currently they've moved to the Lawrence Radiation Laboratory and the University of California, but some people have formed a link right from World War II down to the present studies at Lawrence Radiation Lab.
She had another interesting quote too that ties in with that, and she talks about some of the first modern studies on workplace causes of cancer, the dangers of medical and environmental hormones, and the cancer-causing properties of tobacco were carried out and published by scientists around 1936, including many who worked in Nazi Germany.
Yeah, I read about that conference against the dangers of smoking in Germany in 1936.
And she goes on, she says, in June 1945, Robert R. Kehoe, an Army captain who was a member of the Office of Strategic Services, the OSS, traveled throughout Germany gathering information on chemical and hormonal hazards for the U.S. Army Field Investigations Unit and the British Secret Service. 60 years later, these files remain unpublished.
A lot of American financing has gone into how to use that information as chemical, biological warfare.
I see. So probably national security is the reason that it's never benefited the public?
I think so. And it has extended into the virus theory, and it works against environmental causation of cancer and creates myths about cancer causation and so on. So it's hard to separate ignorant results from deliberate propaganda results.
Well, maybe we can go on to untangle some of that in another show. I'm afraid we're out of time again, Raymond. It's been fascinating and fun, and it's gone by too quickly. But
okay.
But we'll hopefully talk to you very soon.
Okay.
Thank you very much, Raymond.
Bye.
Goodbye. And we've been talking to Raymond Peat, endocrinologist, physiologist, and science historian from Eugene, Oregon. Raymond Peat has a website. It's called Ray Peat, R-A-Y-P-E-A-T, all one word, raypeat.com, where you'll find many interesting articles covering subjects of science history and health and nutrition. If you have any questions for Politics and Science, you can direct them by email to politicsandscience@madriver.com. That's politics, A-N-D, science @madriver.com. Politics and Science can be heard weekly on WMRW LP Warren 95.1 FM, airing on Mondays at 5 p.m. and Sundays at noon. And in the Bellows Falls area can be heard on Wool LP Bellows Falls at 101.1 FM, airing from 3 to 4 p.m. on Sundays and from 9 to 10 a.m. on Mondays. Politics and Science presents the viewpoints of its participants and does not necessarily reflect the viewpoints of any other person or organization.